Good morning, everyone. Myself Kishan Shinde, currently pursuing my engineering at 7th SEM in Sri Venkateshwara College of Engineering in the domain of computer science with artificial intelligence. Today's topic is representing knowledge in an uncertain domain. Come on, let's dive deep into this topic and explore whatever we can. Introduction to representing knowledge in an uncertain domain. Uncertain domains refers to area where there is incomplete or ambiguous information. Advanced AI systems need to be able to handle uncertainty in order to make accurate decisions. Representing knowledge in uncertain domains is an essential for AI systems to effectively operate in real-world scenarios. So uncertain domains where the AI systems which works on day-to-day basis or an environment should be aware of uncertain domains. So uncertain domains is a major role where it determines whether the AI systems are accurate or not. So it should be aware of uncertain domains which causes variations in AI systems to give us a correct output or result to uh, the human beings. So let's see what are the challenges in representing knowledge in uncertain domains. Uncertainty arises due to limited data and conflicting information or changing circumstances. Representing uncertainty requires capturing probabilistic relationship between variables. Balancing the trade-off between accuracy and efficiency is a major challenge in uncertain domains. So, as it says, AI system which is limited with data or limited with information is a greater cause of raising uncertainty. So, conflicting information in the sense information given now and information given then would be conflicting to each other or contradictory to each other, which causes the uncertainty and changing circumstances. Every moment, the environment around the AI would be changing, and this could cause uncertainty. So the uncertainty in probabilistic relationship between variables. If the probability of variables is very less, then the uncertainty is mandatory. If the probability is being maintained properly and uncertainty is handled, then the AI system would give a proper result. So there is always a balancing between the accuracy and efficiency. If the models are accurate, the efficiency would be less, and if it is efficient enough and the accuracy would be less. So the balancing between trade-off of this both parameters is very challenging, and it causes an uncertain domains. Probabilistic models in representing uncertain knowledge. Bayesian networks are graphical models that use directed acyclic graph to represent probabilistic relationship among the sets of random variables. They are widely used in uncertain knowledge representation in various fields such as healthcare, finance, and natural language processing. Bayesian networks allows modeling dependency between variables and make probabilistic inference based on observed evidence. Bayesian networks is a type of model which makes model or builds a model to give us a correct output based on the variables around the environment and makes a probability between the observed evidence and unobserved evidence. So this model is in contact with the random variables that is causing an uncertainty uh, and determine the evidence properly and give us the result. So this is widely used in healthcare, finance, and natural language processing. Markov decision. Markov decision is undirected graphical model that represents probabilistic relationship among variables. They are used in situations where BNs might not be sufficient, especially for modeling complex interaction between variables with symmetric data. As the definition says, the Markov decision is an alternative for Bayesian networks where Bayesian networks is insufficient or inaccurate or inefficient enough to give us the result. Markov decision come into place and gives us the proper result to that. Hidden Markov model (HMM) are statistical model used to model a sequence of observed variables whose underlying states are hidden or not directly observed. So they are widely applied in the speech recognition, bioinformation, and natural language processing for modeling sequential data with uncertain state of transitions. So hidden Markov model is an alternate, not an alternative. It is an part of an Markov decision model where it hides the variables or observables, and it is not directly identified, but it is hidden behind and works on the variables and gives us the proper result. So this is widely used in speech recognition, bioinformations, and natural language processing. Fuzzy logic for handling uncertainty. Fuzzy logic allows us for representing an imprecise or vague information. Fuzzy sets and membership functions are used to assign degrees of membership to elements. Fuzzy rules and fuzzy inference engines enable reasoning and decision making in uncertain domains. Fuzzy logic helps in handling imprecise data. Traditional logic relies on crisp binary values, whereas fuzzy logic allows for degrees of truth. This is particularly useful when dealing with the data that's not clear cut and contains ambiguous or imprecision. Linguistic variables and fuzzy sets. Fuzzy logic uses linguistic variables and fuzzy set to represent vague concepts linguistically. For instance, terms like hot, cold, fast, slow can be represented in fuzzy logic to capture the inherent uncertainty and subjectivity. Membership function. Fuzzy logic employs membership function to assign degrees of membership to elements in a set. Instead of strict categorization, membership functions enables a graduate transition between being a member or not, allowing more representation of uncertainty. Artificial intelligence approaches for uncertainty knowledge representation. Reasoning, fuzzy logic, ontology with uncertainty, and bias in networks in AI planning. Probabilistic reasoning that you already seen behind that bias in networks or Markov model or hidden models are extremely used in probabilistic reasoning. Fuzzy logic we just saw through now. What are the fuzzy logics? And ontologies with uncertainties are augmented with probabilistic extension or fuzzy logic can handle uncertainty knowledge representation. These ontologies allows for explicitly representing an uncertainty in relationship between entities in a domain. Bias in networks in AI planning. Bias in networks are integrated in AI planning systems to model and reason about uncertainty states, actions, and outcomes. This incorporation of uncertainty helps in decision making under partial observability. Evaluation and validations of uncertainty representation. Metrics such as accuracy, precision, recall, and F1 score can be used to evaluate performance of uncertainty knowledge representation. Cross validation technique can access the generality of the model. Real world testing and user feedback are crucial for validating the effectiveness of uncertainty knowledge. And we could also use a confusion matrix which is given in the picture below there, which gives us the true negative, true false positive, and false negative and true positive. Applications of uncertainty knowledge representation in advanced AI. Automatic driving cars rely on uncertainty knowledge representation to navigate complex environments. Healthcare system uses uncertainty knowledge representations to assist in diagnosis and treatment decisions. Financial prediction model leverage uncertainty knowledge representation to make informed investment choice. Conclusion. Representing the knowledge in uncertain domains is crucial for advanced AI systems to make accurate decisions. Probabilistic model, fuzzy logic, and machine learning and hybrid approaches are used to handle uncertainty effectiveness. Ongoing research and advancements will continue to improve and represent the uncertainty knowledge of AI systems. Thank you. I hope you understood the topic. Please do like, share, and subscribe.